Today we will talking about the burette method for protein. First, in 2008, there is a famous incident with melamine. Okay, and because in the Candel nitrogen method, you will have a high protein nitrogen value if you add melamine, urea, and ammonium sulfate. So this research they show that if you add melamine to milk and use the Candel nitrogen method, you have a higher value. And also, if you add urea, you also have very high value of protein. But if you use burette method, the major protein value is set for melamine adaptation, also ammonium sulfate and urea. So if you want to have a selective detection and a specific detection, you need to use a spectroscopic method for the protein measurement. Okay, so we will use a protocol in this document. Okay, so we use the following chemical reagent. We use copper sulfate pentahydrate, and also we need to use potassium sodium tartrate tetrahydrate. And if you want to preserve the burette reagent, we need to have potassium iodide. But today we don't use potassium iodide. And we also need some volumetric flask. Okay, so this is our chemical reagent, and we also need to have sample. So this is our sample, milk powder, and for the protein standard, we use. Okay, so this is our protein standard, albumin. Okay, so this is albumin from chicken. So this is our protein standard. Okay, for the experiment, we need to prepare the burette reagent. Okay. So this reagent, first step, we use 1.5 gram of copper sulfate pentahydrate. This immediately is Yosan-Top. Okay, so we add 1.5 gram of copper sulfate pentahydrate, and also 6 gram of sodium potassium tartrate. Okay. But for today, our volumetric flask, we don't use 1,000 milliliter. We use 100 milliliter. Okay. So in case we use 100 milliliter, we will reduce our reagent proportionally. Okay. So we use 0.15 gram of copper sulfate pentahydrate and 0.6 gram of sodium potassium tartrate, and the water we use is 50 milliliter. Okay, and because the burette reagent we need to react under the basic condition. So we use sodium hydroxide. In memory is 氢氧化钠. Okay, so we add 氢氧化钠 10% sodium hydroxide, and the volume is 30 milliliter. If we use a small flask in this, like this. So this is the flask we use, and we don't use 1 liter because all we need is 100 milliliter. And if you want to preserve the reagent, you will need to add potassium iodide to the urate reagent to inhibit the reduction of the copper. Okay, but because we use reagent today, so we just skip this step. Okay, and this is a preparation of the urate reagent. I also have a handout. So this is a handout I put in the e-learning. In Mandarin. So this is the same as the protocol we use. But this is for 25 milliliter flask. But as I mentioned, we can just adjust the weight proportionally compared to 1 liter. That is 1,000 milliliter. Okay. But we don't use 1 liter because that is too much for our experiment. And for the protein standard, we follow the step like here. And so we just adjust the weight and volume to our flask. Okay, so just like the handout I put in the e-learning. The first step is a urate reagent, and the second step we prepare the protein standard. But the flask we use not 25. We use also 100 milliliter volumetric flask. This is a volumetric flask. 定量瓶 in Mandarin. Okay, so we use this as our flask. So if we use 100 milliliter, we'll need to adjust the protein weight of 1 gram. Okay, so this is our protein standard albumin. We weigh the 1 gram, 1 gram of the albumin, and we dissolve into 100 milliliter flask. So we'll prepare this in the flask. But this cannot dissolve easily. So first you will need to dissolve this into a beaker. Okay. So take a small beaker and weigh 1 gram of your protein standard and dissolve in the beaker. After you dissolve, you put in the flask. But if you put this albumin in the flask, it will not easy to dissolve because they have some tendency to aggregate. They become a small cluster, and it will not dissolve easily in the flask. So even you shake very hardly, and they still have some cluster, some small particle that cannot dissolve. So in the preparation, use the beaker to dissolve your protein. And after this dissolve completely, I mean 完全溶解, okay. So if you have the protein dissolved completely, 完全溶解, okay, then you put the beaker into the flask, okay. And the same is also for the urate reagent. For the urate reagent, we use this copper sulfate, pentahydrate, and also the just in the previous page, we have a sodium potassium tartrate. So the same as a protein, we dissolve this in the beaker. If you put the reagent directly in this, you will have some cluster or some deposit on the surface. Not easy to dissolve, even you shake very hard. So first, put the copper sulfate in the beaker, and also the sodium potassium tartrate. After you put the two reagent inside the beaker, put 50 milliliter of water. Here, you change this to 50 milliliter. 50, okay. And after you have this, you add 10% sodium hydroxide.